That boy ain't right. All right, chapter 10. What, you're talking shit with me having like this teacher having the same thing? Classes are cool.
I know I was wearing green glasses for a minute, but I don't want to read.
Chapter 10, this is on solving systems of equations. See, I wish I could pull off what girls can that wear glasses. They can have that whole super sexy librarian look with the glasses and the hair up like that, and they let the hair down and they do this shit. And all of a sudden it's just like, it's sexy.
Do I have that look?
I am not gonna say you have that look. Because that would be harassment.
That would be correct.
I am an instructor, I get
I'm just
like
kidding,
that.
I'm just kidding.
That's just, especially with me being recorded, you're just trying to fucking frame me now. Jesus. All right, so,
Come on, we talked
sis-
about men, we talked about a lot of things.
right, but I can't
I'm just,
say inappropriate content as an instructor.
oh, I didn't know it was inappropriate.
If any teacher ever tells any student in
I
any
thought that was
class
insane though.
that they look sexy or they don't look sexy, it's inappropriate. I shouldn't be commenting on a student's look.
You're right.
All right, so solving systems of linear equations. Systems are when we need to solve more than one equation at once. When we have more than one equation to solve,
Wait, what's it say? Chapter 10 what?
solving systems of linear equations. Oh, I'm off the screen. Thank you. I didn't check the zoom scale.
Well, at least I have my glasses now, you don't have to zoom in.
Good. When we have more than one equation to solve simultaneously. This is called a system of equations. And there's several methods we're going to go about doing it. The first approach we're going to take is graphing. So approach A is graphing. And what the way it works is step one, graph both lines. Two. The solution is the point of intersection, if any. Okay, so here's our scenario. Example, we have an 8-foot board. Two by 4 piece of wood. And we want to cut it into 2 pieces. With one piece 2 feet longer than the other. What sizes will we have? Set up a little graph. We need to work on the equations first, that way. So let's say I got this piece of wood. And one side needs to be a little bit longer than the other. Let's say the short one is X and the longer one is Y. And when I'm saying it, X is the length. X and Y are lengths. All right, so it tells us that the two pieces are, the board was 8 feet long in the first place. That's important to know. Which means if I add up the lengths of X and Y, if I add X and Y together, I should get my 8 feet. And if we make X is the shorter board, X is shorter, and Y is the longer board. The longer board is 2 feet longer than the short board. The longer board, which is Y, is 2 feet longer than the shorter board, which is X, so 2 plus X. I have two equations here. And I can solve them. I'm going to rewrite them. I'm going to call this one, I'm going to subtract the X over. And then we'll go about graphing. Because if you've been doing your homework, we did this a little bit, talk about graphing these. If I wanted to graph Y equals negative X plus 8, this has a Y-intercept of 8. And it's got negative X, which means M equals negative 1, which is really negative 1 over 1. So I can go down 1 and right 1. That's my Y equals negative X plus 8. copy stain on this piece of paper really shows up well on the fucking screen. I could barely see it from my angle. The other one, x plus 2, I have an intercept at 2. And here they've got no number in front, so m equals 1. And I can write that as 1/1. Which means I go up 1 and right 1 as I go. And that's my y equals x plus 2 line. They cross right here. So this is, that's 3 right there, right? It's between 2 and 4. And that's 5. So my x length is 3. And my y length is 5. And that's in feet, since we're talking about lengths. We can check it. Do they add up to 8 feet? Yeah. Is one 2 foot longer than the other? 5 feet is 2 feet longer than 3. So yeah, we meet that one too. So that's the idea of solving them graphically. Any point on a line is a solution for that line. And so if we wanted to solve both lines, the solution we're looking for has to be on both lines, and that's where they cross. So that's our solution right there. Any questions? This is not the ideal way to do it. There's better ways to do it. Graphing can be time consuming, take up a lot of space. We'll show you how to do it other ways. Is there any questions online? Anybody over there that has a question? So you just graph the lines and you look for where they cross.
Will do.
Bernardo and Eunice. Bertha is supposed to be showing up on there, unless Eunice is Bertha.
Yeah, Eunice is Berta. Hi.
Hey,
That's my second name. Hi. Hi, everyone.
Hello. Anyways, was that one?
yeah, she needed to stay home today. You could sit in the front now. What? Did I miss something? Who gestured up here? All right, quit fucking with me, guys. All right. So another one we want to look at is inequalities. So we can do the same thing for solving systems with inequalities. I am not going to test you on this, but I'm going to show you how it works, just so you've seen it. Okay? Because we didn't really do a lot of graphing for inequalities. We had a little bit there, but we didn't put it together.
Is that where you shaded?
That's where we shade it, yeah. So here we're gonna do it graph like normal.
Inequality.
Inequalities. Graph like normal with the shading. And 2, the solution region is the area of overlapped shading. I can't think of a problem where you might have this in a trade thing, but they might have it somewhere. So you need to see it, but I'm not testing you on it. If you have it in the future, your skill set, you'll have seen it. It's not the most intuitive thing for students. So let's just put up 2 lines. We're gonna do y is less than or equal to 2x plus 3. And we're gonna do x plus y is greater than 4.
Brackets.
We're not gonna do the interval notation for this. It's you'll see that it's not really convenient to do interval notation for this. We're just gonna do graphically the picture and highlight the regions. So maybe I'll rewrite this one by subtracting x. This one becomes y is greater than negative x plus 4. Let's graph that one first. Let me put some scales here. So that should work. If I need more, I can draw more lines. Negative x plus 4, I start at the y-intercept of 4. The slope here is -1. So I'm going downward. And the fact that it's there's no equal sign means I just leave the line dot. I do not fill in the line. So that is my y is greater than negative x plus 4. I want numbers that are greater than it. I will test 0 here. If I test 0, 0, which is right there, and I plug it in, I get 0 is greater than 4. 0 is not greater than 4, so that's false. So I'm going to shade on the other side. I'm going to shade up here.
Is it the 0, called origin?
It's called the origin, yeah.
I remember something from high school.
I also said it last week.
Oh, I think I wasn't there last week. Or did I?
They're selling me some bullshit right now.
Because I was.
By the way, good. It's good that you remember. All right, so then we've got y is less than or equal to 2x plus 3. I put my y-intercept at 3. And this tells me I go m equals 2 here, which means I can go up 2 and over 1. And I can go the other way, go down 2 and left 1. This does have an equal sign, so I actually draw the line here. I don't make it dotted. If I want to check the regions for overlap, I can plug in 0, 0 because 0, 0 is not on the line. And I get 0 is less than or equal to 3, which is true. So anything on this side of the line. So where they overlap is right here, right? That covers both. There is green stuff down here, but there's no red with it. And there is red stuff up here. But there's no green with it. So the blue area is the area of overlap. And so any point in this region works. We can test it. Like right here. Is, let's see, right there. That point is 5, 5. If I plug in 5, 5 into both equations, it should work in both. Is 5 less than or equal to 2 times 5 plus 3? 5 is less than or equal to 13. That one works. And is 5 greater than -5 plus 4? -5 plus 4 is -1. 5 is greater than -1, so that one works. Any points in that region work. Any points on the green line in this region work. Because the green line is part of the answer. The red line is not, so points that are actually on the red line don't work. So that's how you solve systems inequalities graphically. When we do the regular ones, just the regular linear equations, there are 3 possible outcomes that you can get. When the lines cross, wait, I think I'm rushing this. Make sure everyone's done with the graphing part. All right, so lines that cross at one point, like the example we did, these are called, this is called an independent system. I'm not testing you on this knowledge right here. Lines that don't cross are called inconsistent. And this really only happens if they're parallel. If they aren't parallel, they cross somewhere. They may not, if you try graphing it, they may not cross where you tried graphing, but they will cross somewhere. And lines can completely overlap. Which means any point on the line works for both. They call this a dependent system. If it comes up in the homework, that's what that shit means. I'm not testing you on those names. I don't think the names are really important unless you're going to be like a math major. I don't think the names are important to people like engineers and stuff, and they do a lot of math. It's really only some math geek shit right there. You guys ready?
So since lines can completely,
It's basically through the same line,
overlap.
completely overlap, yeah. Overlap. And we'll see examples of these today. I'll show you an example of both the inconsistent system and an independent system. What's up, Two Eyes?
I need to know, I don't even wear glasses. That's fine.
That's what.
All right. Okay, so graphing is usually, you have to like know the right about area where they're gonna cross to make a graph reasonable. So graphing is not the ideal way to go. In fact, the only reason those were good to graph is because I picked values and I knew what I was doing when I set up the equation, so they'd be close to 0 and we could find it. So there's a couple other methods to do it. 10.2 has solving with addition. It's called the addition method. The first way we'll look at is if the two equations contain a term that have opposite coefficients. This is the first way. What we're going to do for these is we are going to add the equations together. This will cancel out one of the letters. A variable. B. Solve for the variable we have left. We plug this value into one of the original equations. And solve for the remaining variable. This will give us both values. At this point, we now have both values. Finally, check the solution in both equations. And like. These steps right here. These steps are the same for all the methods. Only the steps before it change. No matter which method you use, you're gonna get it down to. One equation with one variable in it that you solve. Why are pastries at Mexican bakeries not sweet? Why are pastries at Mexican bakeries not sweet?
One of the same thing.
Like some of them even look like they're dusted with sugar. And they're still not sweet. I'm fucking confused.
Compared to just regular one.
Yeah,
They use like a different type of pulp or different type of sugar. They can use.
like cane sugar. I mean, what sugar isn't sweet?
So there's the brown sugar. And it's supposed sweet.
Brown sugar is sweet as hell.
Well, no,
Have you had it in oatmeal? Brown sugar and fucking oatmeal is awesome. I don't know. There's something about it.
What about Bertha?
What about Bertha?
Finance.
Do you think you can change?
Bertha, do you think Mexican pastries are sweet?
Some of them,
Really?
there's some that actually have salt. They're kind of salty.
The
Like the
salt
corn-
might make the sugar pop. I can
Like
see
the
that.
like the conchas. I don't know how they're called in English though. Like only the top part is kind of sweet.
Okay.
It's like a certain kind of person.
Like throwing M&Ms in a bucket of popcorn at the movies is fucking awesome. It grosses some people out, but like salt and sugar really pop. All right.
Yeah.
Take a look at one to give you guys some time to write that. And we went, my wife and I went to Juanita's Bakery. It's down the street on Barsley, down near the Burger King down there. And we went there this weekend and we got a couple pastries and like, even the one that looked really looked like it had cherry or strawberry like jelly in it. Fucking even that wasn't that sweet.
I don't like things that are filled in.
It was not, it was a very thin layer. Like my wife took one bite and threw it away. It's like, why eat this? There's better, if I want sweet, or if I want, this is just empty calories. I'm not gonna do
Wait,
this.
did you say here it's Larry?
Yeah, it's right down the street down Barkley. It's called Juanita's Bakery. It looked new. We went in there. That's some nice rolls. I like bread. All right, so
Next to the old Arnon that was there.
a little bit further down, but yeah.
Okay.
All right, so let's have x plus y equals 7 and x minus y equals 1. This is gonna be our example. What we do is we add them together. What is x plus x?
2x.
2x. What is y plus negative y? No,
Negative y to the second power.
that would be multiplying. Well, that's
Y?
What is y minus y?
Y, just one Y, right? Positive? Oh, no, 0, sorry.
0. If I got one Y and I take the Y away, I've got 0 Ys.
Oh.
So those cancel out. That's the principle we've been doing. I threw you off with the way I worded it, I'm sure, because that's what we've been doing all along. 7 plus 1 is 8. So I have 2x equals 8. I divide by 2. And I get x equals 4.
It's a fun one.
We take that, we plug that into either one of these. I recommend plugging it into whichever one looks like the easiest to solve. I think the top one looks easier to solve here. I've got 4 plus y equals 7. So if I solve for y here, I get y equals 3. My point is 4, 3. If we graphed them, that's where they would cross. And we could check these in both equations. If I do 4 plus 3, x plus y is 4 plus 3, I get 7. If I do x minus y, I have 4 minus 3, and I get 1. So it meets both equations. Okay, everyone good with that? Let me give you guys one to try. Try this out. Do it together and it's
I have a question.
Yeah,
So when it's y, it would be the answer, so it would be 72, or would it be x?
say what?
Okay, so what I got for y was 2.
Okay,
So now I'm plugging it in to -4x plus 7, but I'm saying,
oh, it's multiplied, it'll be 7 times 2.
okay, so it would be in parentheses.
Yes.
It's all one equation, right? There's 2 separate,
What?
it's all one equation, right?
Those are 2 equations.
2 separate ones?
Yeah.
Yeah. There's 2 lines. Wait, this long to ask me that shit? Get out.
No, I was trying to though, but I couldn't study.
Alright, so if we add them together, what do we get?
What?
24.
I thought it was separate equations.
They are, but we need to solve them together. You not catch what we did in the last fucking problem? We
It's
solved
just
them
the-
together. Oh, bless your heart.
+4.
That's a bless your heart on right there. The 4x's cross out, right?
What's going on?
Damn it.
0.
12.
That's 12y. You even said y equals 2.
Yeah, but I was doing it like
We-
separate.
There's no way you did it separate, because you shouldn't have gotten y equals 2.
I did.
Y has an infinite number of solutions on any line. You'll have to show me what you did in a little bit.
It's 2 separate ones.
We divide by 12 and we get y equals 2.
Okay, yeah, I thought so.
Then we take this, we plug this into one of the other ones.
It's because the 4's cancel out, right?
Yes, force cancel out. This is like 0x. If I stick in y equals 2, I've got 4x plus 5 times 2 equals 14. I could have stuck it into the other one, but I don't like dealing with. I chose the one that has a positive x on it. I don't like having negative signs on my coefficients if I can avoid it. This is 10, so I've got 4x plus 10. Subtract 10. We get 4x equals 12, or 4.
Like,
Divide by 4 and we get x equals 1. The answer is 1, 2.
What see?
Sure.
Because I thought it was.
Okay, what you did here, you added them up here, you did add these. Or is that
No,
you just
this
figured out?
was what I did now, but this was beforehand.
Okay,
That's all.
the 4 is times the x, you can't subtract the 4 without subtracting the x with it. That's, okay. Don't you,
'Cause I
that's
thought-
bad.
Okay.
You got lucky with the y, those two there.
Yeah, I did, that's why I got real confused.
Alright. So, check it in both equations. 4 times 1 plus 5 times 2, does that equal 14? And then does -4 times 1 plus 7 times 2, does that equal 10? Here I've got 4 plus 10 equals 14. That's true. Here I've got -4 plus 14. Does that equal 10? Yes, it does. That's true. So 1, 2 works in both equations.
Yeah.
They make you hungry?
But now I know that to put them together instead of separating.
Yes. And don't, whatever you do, don't do what you did on that paper ever again. They stay linked, the x has to stay with the 4. I'm glad you showed me that maybe. Because it's like saying, instead of saying x, saying you have 4 candy bars. Or 4 bread rolls. And then just saying I'm gonna subtract the 4 doesn't like. If I try to eat the 4 bread rolls and I only get rid of the 4, I'm still left with the bread rolls there. But now I don't have even a number on the bread rolls, it doesn't make any sense, I gotta have a
I
number.
was thinking like 0 and 4, like have your positive or you have your positive. You have your positive 4 and you have negative 4.
I got it, I saw what you're doing. The problem is it was multiplied by the x, you cannot do it that way. The 4 is multiplied by the x, you can't just subtract the 4 off. The way we get rid of it, like here. See how I got rid of the 4 here with the 4x? You do it by division, you can't do it by subtraction.
That's why.
There we go. All right, so if they don't have. Equal and opposite coefficients. We force them to. By multiplying. One or both equations. By numbers. To make them have it. Opposite coefficients. All right, let's take a look at an example. We're gonna work with x plus 2y equals 7. And x minus y equals -5. Those are my two options. I'm gonna show you doing them either variable. Option A. Make the x's have opposite coefficients. Right now, they both have a positive 1 in front of them. If I want to make this happen, both have 1. I need to make one of these a -1x. That way, when I add them together, (1x plus -1x equals 0x). So what I'm gonna do is I can pick either one. I'm gonna pick this one over here. If I want to make a +1 into a -1, I gotta multiply it by -1. And if I multiply the left side by -1, I have to multiply the right side by -1. If I do this, when I multiply -1 times x, I get -1x. And I'll put that over here underneath it, so when I add vertically, they cancel. And when I multiply -1 times -y, I get +y. And when I multiply -5 times -1, I get +5 as well there. So now one of the equations is still the same one I started with. The other one is just a change of signs. Now when I add these up, I get the x minus x goes away. 2y plus y equals 3y. And 7 plus 5 equals 12. So when I solve for y, it's multiplied by 3, so I'm going to divide by 3. And I get y equals 4. And I can stick that into one of my equations. Let's do this one up here. The x minus y equals -5. If I put in if I put in 4, I get x minus 4 equals -5. Add 4 to both sides. I get x equals -1. So my solution here is -1, 4. When you check your work. Do it in the original equations. Before you multiply by anything.
Just let me get out first.
Alright, so let's check it in both of these up here. X plus 2y equals 7. If I plug in x is -1 and y is 4. Do I get 7? I got -1 plus 8. That does equal 7 and that works. When I check it in x minus y equals -5. I've got -1 minus 4. Does that equal -5? And yes, we get -5 on both. All right, let's look at the same one again, doing the other way. So same problem, option B. Make the y's have equal and opposite coefficients. Right now, I've got a 2y and I've got a -y. If I want to make the 2y look like the -y but positive, I would have to multiply by 1/2. I don't like working with fractions, so let's avoid that one. The other option I have is I can turn this into -2y. By multiplying by 2. So we're going to do that. I had x plus 2y equals 7. Got x minus y equals -5. And we're going to multiply this equation right here by the 2. So do the same thing. And I got to distribute the 2 to each of them. 2 times x is 2x. And 2 times -y is -2y. Two times -5 is -10. If we add these up, the y's cancel out, and we're left with x plus 2x equals 3x. And 7 plus -10 is -3. Divide both sides by 3, and we get x equals -1. I'm gonna take that and plug that back into one of the original equations. I'm gonna plug it into the x plus 2y equals 7. If I add 1 to both sides, I get 2y equals 8. If I divide by 2, I get y equals 4. And I put them together and I get -1/4. Again, if this is the way you did it. Check your work. We've already checked our work for this solution on the other page though. Are you guys ready to try one like that? Work for it? Let's do 2x plus y equals 4. 5x plus y equals 13.
Positive and positive equals a negative.
What? No,
Or positive.
two negatives equal a positive. Positive, positive is a positive, negative, negative is a positive. Positive and negative are negative. When you're multiplying, I assume that's what you're talking about.
And a decimal.
All right. So probably the easiest one to deal with is the Y's. Because I haven't really shown you how to deal with when they have coefficients like this that are crap. We're doing that next. So maybe I'm gonna take this one and maybe multiply this one by -1. That will give me a negative Y. Multiplying by -1 just changes all the signs. If I add them up, I get 3x equals 9. Divide by 3 and I get x equals 3. So we had 2x plus y equals 4. That's the one that's got the smallest coefficients. I'm gonna plug it in there. 2 times 3 plus y equals 4. This is 6 plus y equals 4. Subtract 6, and I get y equals -2. My solution is 3, -2. Gonna do two more kind of quickly with you. You'll see why there quickly in a second. If I multiply this one by -1. I get x plus y equals 7, negative x minus y equals -5. And when I add them together, both the x's and the y's go away. And I'm left with a 0 on the left. And on the right, I have a 2. Does 0 equal 2? No. This is not true. Which means there is no solution. These are actually parallel lines. And the homework, when they do it, they might tell you to write inconsistent. The other one we'll do a little bit quickly is. Nope, where am I going? Let's try that again. 3x minus y equals 11. And 6x minus 2y equals 22. All right, so I think the easiest thing to get rid of, maybe, I don't know. The y, if I just double the y, maybe change the sign, if I multiply by -2 on this line. This would give me, if I do that, that will give me a positive 2y there. And that's what I'm aiming for. The y's look like they're kind of easy to get rid of. So if I multiply by -2, I got -2 times 3x is -6x. -2 times -y is plus 2y. And -2 times 11 is -22. When I add these up, I get 0 equals 0. That's true all the time. It's always true. These are actually the same line. Or they completely overlap each other. So any point on the line is a solution for both. This is called the dependent system. And since it's dependent, since if they overlap, any point works, there's an infinite number of answers that work. Infinite number of solutions. All right. One more topic in this section. I'll do an example with you together and then I'll give you one to try and then we'll be done. So now this is when they have coefficients that have nothing in common. Two x plus 5y equals 1. 3x plus 2y equals 5. All right, so if I want to get rid of the x's, let's just look at all our options. If I want to get rid of the x's, I could multiply this by, I wanted to make it a negative 3x. So I could multiply by negative 3 halves. These are options. If I did negative 3 halves, it gets rid of x. When I add them together. Because negative 3 halves times 2 is negative 3. And then that would be the opposite of the 3x. Bad choice. It's got fractions. No, don't do it. No. Fuck fractions. Anything that would result in a fraction means really hard work later on. If I tried to do the other one, if I wanted to do x's in the other one, if I want to turn 3x into negative 2x, I have to multiply by a 3 on the bottom to get rid of my 3's, and I got to multiply by a negative 2 on top. Again, this is a fraction. No, don't do this. Bad juju. The same thing happens with the y's. So when we have coefficients or numbers in front that there's just nothing that works, one is not a multiple of the other, the easiest way to go about it is pick a letter to get rid of. And then multiply each equation by the other's coefficient. Making sure one is negative and one is positive. I'll show you both. We're only going to solve one of them though. We already saw that doing both of them gets the same solution. So let's say, let me pause, make sure everyone's done writing. Getting all hasty here. let's deal with X. So I'm gonna rewrite my things down here so that I can see them again. So what I'm gonna do. Is I'm gonna multiply this line, the other line has a coefficient of 3. I'm gonna multiply this line by 3. This one's got a coefficient of 2, I'm gonna multiply this one by 2. And since neither of them, they're both positive right now, I'm gonna choose one of them to be negative, I'll make this -2. If I do that, if I multiply by 3, make sure you hit each thing. 3 times 2x is 6x. 3 times 5y is 15y. And 3 times 1 is 3. You gotta hit each thing. -2 times 3x is -6x. -2 times 2y is -4y. And -2 times 5 is -10. Then we saw like we did everything else. We add them together. In this case, we were dealing with the x's. If you do it right, you're gonna have the same number in front of both, but one is negative. 6x minus 6x is 0x. I've got 15 minus 4 is 11y. Oh crap, I didn't write down what I wanted to. This is gonna have fraction answers, son of a bitch. I'd rather change it. Let's go back and change it. Let's make this -4 right here. And multiplying that by -2 will give me an 8 over here. Wait, that's still doesn't fucking work. Tripping out. Hold on a second. Oh yeah, I did. When I added up, they add up to 11. Duh. Finish adding the right side here. That's the problem. Equals 8 equals 11.
How you're gonna do.
Now we divide by the 11. And we get y equals 1. I will stick this into one of the original equations. 3x plus 2 times 1 equals -4. That's 3x plus 2 equals -4. Subtract 2 and I get 3x equals -6. Divide by 3 and I get x equals -2. The answer is -2, 1. And if we had more time, we would do it in class, but you should always check your work by plugging it in. Check your solutions. Gurgle, gurgle. If we had wanted to get rid of the other one. Oh wait, slow my ass down, push away. I'm gonna rewrite those equations. And now if we wanted to get rid of y. This has a 5 in front of it. So I'm gonna multiply this line by the 5. This line has a 2 in front of it, so I'm gonna multiply the other line by a 2. Both of them are positive, so I'm gonna use make one of them negative. And I tend to do the smaller number. I don't know why, just that in my head, it makes things easier. But that's probably just, I don't know if that's just a lot of experience and I'm subconsciously aware of some shit that I can't put into words. I just always do it on the smaller one. If I do that, if I do -2 times 2x, I get -4x. -2 times 5 is -10y. And -2 times 1 is -2. (3x) times 5 is 15x. 2y times 5 is 10y. That's good. We were going to have y cancel out, and we can see that they will. And then -4 times 5 is -20. When you add these up, you'll see you get 11x equals -22. Divided by 11, we get x equals -2. And I can put it into either equation. I'm going to put it into the one that has a smaller coefficient for y, just because I like smaller numbers. So I had 3x plus 2y equals -4. I'm going to plug that x equals -2 right there. We had 6 to both sides. We get 2y equals 2. Divide 2 on both sides and we get y equals 1. Put these two together and we get the point -2, 1, like we did up above. You can see you get the same point. You guys ready to try one? And then we'll be done. I'm gonna give you some advice, but I want to see which one of you guys would think you would want to work with here. Should we try to get rid of the X's or should we try to get rid of the Y's? Why? I agree. There's already a negative.
Yeah.
That's a perfect reason. One of them's already negative, one of them's already positive. So if I multiply, I'm multiplying by positive, I'm less likely to fuck it up with a sign mistake. That's a good choice. So focus on getting rid of Y's. And then we'll do it together in a few minutes. Tonight. So you guys can plan your next one. Alright. So. We're gonna get rid of the y's, which means I'm gonna take this 2 and multiply it over here. This 3 and multiply it over here. 4x times 2 is 8x. Negative 3y times 2 is negative 6y. And 23 times 2 is 46. If I do that here, I've got 3x times negative or times 3 is 9x. 2y times 3 is 6y. And negative 4 times 3 is negative 12. Hopefully you got those. We add these together, we get 17x equals 34. Divide both of them by 17, we get x equals 2. I'm gonna stick it, did you get that?
No, I mean,
Did you make a phone mistake?
yeah, I did, I multiplied by -3.
Oh,
Yeah.
yeah, we reason why we chose y, so we wouldn't have to
Yeah.
go with the negative.
I was like,
And it would show up here. If you did -3, you would see that these were both negative 6y, and you know, if that doesn't work.
yeah,
If I stick in 2 here, I got 3 times 2 plus 2y equals negative 4. Subtract 6 from both sides. Divide by 2 and I get y equals negative 5. And that'll be it. What?
These ones have too many steps. And you have 4 different things.
Yeah, there's stuff to do there. On Wednesday, we'll do another method, which is in some cases easier, and then we'll also do a bunch of like example problems where this shit actually shows up. So you'll see how it works, that I'm not just making shit up.
Yeah, Jim.
See you guys, I'll see you guys later.